Welcome to this comprehensive tutorial on efficiently managing game scores in Unity using static utility classes in C#. This guide is designed to walk you through the entire process from initial setup to final testing, ensuring you gain a solid understanding of this powerful programming pattern. A common and often complex challenge in game development is consistently tracking and updating game state, such as a player's score, across various parts of your game. This can become particularly tricky in larger projects where multiple scripts and game objects need to interact with the same score data. Without a structured approach, this can lead to tangled code, difficult to manage dependencies, and errors as your project grows in complexity. Imagine trying to debug a score that's being modified by dozens of different, uncoordinated scripts. Our solution introduces the power of a static utility class in C#, offering a streamlined, globally accessible, and highly organized method for score management. This approach centralizes the logic, making it far more manageable. This pattern centralizes your score logic, making it easy to access and modify from anywhere in your game without cumbersome references. You won't need to pass score objects around or use complex getComponent calls. In this video, we'll guide you through every step, from setting up a new Unity project and writing the static class, to implementing it to add and display scores, and finally, thoroughly testing its functionality. We'll cover all the essential details for beginners. Let's begin by setting up our Unity project. We'll start by creating a new, simple project, which can be either 2D or 3D, depending on your game's requirements. For this tutorial, a basic 3D core project will suffice, but the principles apply universally. Once the project is open, the next crucial step is to add a basic UI canvas to our scene. This canvas will serve as the foundational container for all our user interface elements, ensuring they are rendered correctly on screen. Following that, we'll add a text element as a child of the canvas. This specific text element will be dedicated to dynamically displaying our game's current score, providing real-time feedback to the player. The canvas acts as a dedicated drawing surface for all UI elements, ensuring they scale and render correctly across various screen sizes and resolutions. It's essential for creating responsive and adaptable user interfaces in Unity. The text component, on the other hand, is straightforward. It's responsible for rendering textual information directly onto the screen, which we'll use for our score display. We'll configure its font, size, and color to make the score clearly visible. Now, let's transition to Visual Studio to create our static score manager script. This will be the central brain of our score handling system, encapsulating all the logic related to score manipulation. We'll create a new C# script and name it Score Manager. This name clearly indicates its singular purpose within our project, managing the score. It's good practice to use descriptive names for your scripts. A static class and its static members belong to the class itself, not to any specific instance or object of that class. This means there's only one copy of the static members in memory, shared by all parts of your application. This means you don't need to create an object of Score Manager to use its functionalities. You can call them directly using the class name, like scoremanager.addScore. This simplifies your code significantly by removing the need for object instantiation. To make our Score Manager a static utility class, we modify its definition to public static class Score Manager. This declaration tells the C# compiler that this class cannot be instantiated and its members are accessed directly via the class name. The public keyword ensures this class is accessible from any other script in our project, while static makes it a utility class. This combination provides global access without the overhead of object creation. Inside this class, we'll declare a public static integer variable, public static int score. This variable will hold our current game score, starting at 0 by default. It's the single source of truth for the game's score. Being public allows other scripts to read its value, and static means there's only one score variable shared across the entire application. Any change to this variable is immediately reflected everywhere it's accessed. Next, we'll create a method to increase the score, public static void addScore. This method will add the specified amount to our static score variable, allowing for flexible score increments. The void return type indicates that this method performs an action but doesn't return any value, and inAmount is the parameter for how much to add. This makes the method self-contained and focused on its task. For resetting the score, we'll implement public static void reset score, which simply sets the score variable back to 0. This is crucial for starting new game rounds or handling game over scenarios. This method provides a clean way to reinitialize the score, perhaps at the start of a new game round or after a game over. It ensures that the score state can be easily managed and reset when needed. Each line of code here is designed for clarity and direct functionality, ensuring our score management is both simple to use and robust in its implementation. This minimalist approach reduces potential errors and improves readability. Now, let's create a second C# script named ScoreUI and attach it to our UI text object in Unity. This script will handle updating the visual score display, bridging our backend logic with the user interface. In the ScoreUI script, we need to get a reference to the text component so we can update its display with the current score. We'll use TextMeshBridge UI for enhanced text rendering, which is a common practice in modern Unity UI development. Within the update method, we'll continuously set the text property to display the current score, scoretext.text equals score, plus scoremanager.score. This line concatenates a descriptive string with the actual score value. We place this in update because it ensures the score display is refreshed every single frame, reflecting any changes in real time as they occur. This guarantees that the player always sees the most current score. While update is suitable for this, for performance-critical applications, you might consider updating the UI only when the score actually changes. This optimization can prevent unnecessary processing every frame. Next, we'll create a third script, GamiDistor, to simulate adding points and interacting with our score manager through user input. This script will act as our testing ground for the score system. In GamiDistor's update method, we'll add a condition to check for a specific key press, such as the spacebar, to trigger score additions. This allows us to manually test the add score functionality. When the spacebar is pressed, we simply call our static method, scoremanager.addScore. This adds 10 points to the score, demonstrating how easily you can interact with the score manager from any script. This demonstrates how incredibly easy it is to call static methods from any script without needing to get a reference to the score manager object first. You simply use the class name followed by the method name. This direct access is a key benefit of static classes, simplifying your code and reducing boilerplate. It eliminates the need for complex dependency injection or singleton patterns for global data. Now, let's switch back to Unity and Interplay mode to see our complete score system in action, responding to our inputs. This is where we'll observe the fruits of our coding efforts. As you press the spacebar, observe the score increasing in real time on the screen, confirming our addScore method works perfectly and the UI updates instantly. Each press should increment the score by 10 points. To demonstrate the reset score functionality, we can tie it to another key press, for example, the ARC key, within our GamiDistor script. This will allow us to test the score reset mechanism. Now, back in play mode, after increasing the score, pressing ARC will instantly reset the score back to 0, showcasing the full control we have over the score state. This confirms both adding and resetting scores work as intended. This simple test confirms that both our add score and reset score methods are functioning as intended, providing reliable score management. This robust system is now ready for integration into your game logic. In summary, using a static utility class for score management provides unparalleled global accessibility, simplifying how different parts of your game interact with the score. It acts as a central hub for all score-related operations. It promotes a clean, organized codebase by centralizing all score-related logic in one place, making your project significantly easier to maintain and scale. This approach reduces redundancy and improves code clarity. This pattern reduces the risk of errors and inconsistencies that can arise from scattered score handling logic throughout your scripts. By having a single point of control, debugging and modifications become much simpler. We highly encourage you to apply this powerful pattern to other global managers in your projects, such as a game manager for overall game state or an audio manager for sound control. It's a versatile solution for many global functionalities. By adopting this approach, you'll build more robust, organized, and scalable Unity games, enhancing both your development process and the player experience. This leads to more efficient development cycles and higher quality games. Thank you for watching this tutorial. We hope it empowers you to create more efficient and enjoyable game experiences. Don't forget to like, share, and subscribe for more Unity development tips and tricks.